Hey, there's my microphone. We are down to it. So I have my last hockey assignment here, rip roaring and ready to go. I will say that in the hockey assignment, I was able to do this without a ton of data manipulation. When I did this for my Olympics, I needed to use a lot of data manipulation. I only ask you to run 2 of these non-parametric tests, but I've gone ahead and done all 4 of them in every one of my assignments. My feeling is, or my thoughts are, that you're going to go ahead and in the homework you're going to do 2 of them, and then on your project you'll do the other 2. So that's kind of the way I've set this up, so that you'll get an introduction to all 4 of these non-parametric methods. But if I have time here, I'd like to go through every one of these. Okay, so you see my screen here. I've got my my document. I've got my data loaded. I got the ggplot2 library. I almost always keep that one on here. I got my link to my old project. First thing I actually talk about is ranks. I wanted to talk about ranks because that is actually how almost all of these non-parametric methods work. So what you do is you rank the data. I'm sorry guys, I'm gassy. Is you rank the data here, and so I figured I should run a thing that shows you how we rank it. So the function rank will rank your data, and then I can give it a different method for ties, which I think is kind of cool. And I think too, I had to decide what I want to do with the 0 or the NaN, and this one gives the last rank to the NaN. Which is a little unfortunate. Oh yeah, there you go. Well, I noticed a few things. The very last team didn't have any points. R automatically did the average, but it's not required. The last score there is NA, but if I turned it as the highest rank, 31 is the highest ranked team. So we need to fix that. So if we do NA last, now we see that last team is the worst team. And you should notice too, it changes all the ranks, right? Okay, so next thing we're going to do, or the first one here, so ranks is how we're doing this, right? Really guys, we won't see the ranks again, because R will do that all in the background. So first one I'm going to do is the Wilcox rank sum. And the Wilcox rank sum, what it's going to do is it's just going to look at the median, and it's going to compare the median to a value, or compare 2 medians, much like the t-test did for means, but it'll do it pretty quick here. So let's compute a median. I compute the median. Remember, the median is like the middle. It's like the divider of the highway. Cuts the data in half. We run, so if I have a median of 3, I'm going to ask, is the game played medium, is it 4? Mu equals 4 here. I run Wilcox.test, and I tell NARM, NA, remove the NAs to be true. So I threw away that NA, and I get a very small p-value, so I'll reject the null hypothesis. Just to show you guys, if I changed the mu to 3, I should, oh, I guess I can't actually, true location is not equal to 3, even though that was the median up there, huh? I'm wondering if it's more like 3.5. Sorry, I'm just curious here. Still would reject that one, huh? So I'm going the wrong way. Looks like it's about 3.4, the median is. There you go, look at that p-value. That's a huge p-value, right? Let's put it back to 4, though. Playing around with this, you can actually see where the median is. Remember, the median is non-parametric, so that's why it jumps really crazy. It's not a bell curve. It's not a bell curve. If you want to visualize this, you should think about box plots. So if we wanted to show, let's get a box plot in there. A box plot, we can do the ggplot2, and we're doing our data, and we're doing AES. Let's see, what do we want for our x? Our x value is going to be games played, right? GP. And then I'm going to add to that the geom box plot. And I don't need any more options, I believe. There you go, there's my box plot. So you see the median is there. That's why, by the way, that's why I couldn't put the median at 3 either. It's because there's just like a few teams down here. Most of the teams, 50% of the teams, no, sorry. Yeah, 50% of the teams fell in here. No, what am I saying? In this box, and the box is always 50%, nobody's played more than 4. So there normally is 25 up here. So this is really 75% of the data. And this is only 25% of the data. That's why this median's a little weird here. Okay, cool. So that's that one. Let's get the other two here. If I want to compare two medians, I need a categorical variable. I've used this categorical variable before, the more or less power plays. So let's not talk about that too much. Let's summarize the data. So I make it compute the median. Well, kind of interesting that the points is 4, but oh, those were games played up top, weren't they? These were games played, not points. That's why. So these are a little different. Let's see, I made it to a table too. Oh, a table of just who has more power plays. And so now I'm going to run the Wilcox test. And you see here I did a formula because I want the power plays to be the predictor of the points. So I get a high p-value here. I failed to reject my null hypothesis. This is what I had seen before, actually. Okay, so that's the Wilcoxon rank sum test. There's 2 Wilcoxon tests here, which is a little tricky, folks. Okay, so then the second Wilcox test is the Wilcox sign test. There are 2 ways to do it. I've done both of them here. Essentially, we only do the Wilcox sign test when we have paired data. Students find paired data a little tricky. The natural experiment that I always do is I ask them their boyfriend or girlfriend, what's their height of their boyfriend or girlfriend. Normally people who date have very similar heights. Rarely do you see a really tall person and a really short person date. And the students always challenge me on this, and I tell them, okay, go to Walmart and look at the couples. So the data is somehow paired, and to do the Wilcox sign test you need this paired data. So I have my power play opportunities and my power play attempts, and above I did like which one was bigger, right, to get a categorical variable, but here I'm just going to compare those 2 values. So I've done this 2 different ways here. I've done it with just putting commas in between and saying paired equals true. And then I also did it by just subtracting these 2. And what you'll see here is both of these will give exactly the same result. They both give a p-value of 0.9134. Kind of funny that those are exactly the same. You can do multiple things multiple ways on the same test. Again, we're going to fail to reject the null hypothesis. It really well, this one's a little different than the other ones. It's like there is no. It's like your team. One team might take more penalties just overall than another team, and what we're seeing is that those are not. There is no trend there. If you take more penalties, does the other team take more penalties? We don't see any trend. So we did not reject the null hypothesis. So there we go. All right, let's stop this one. I'm going to stop this video, and I'll make a second one for the other 2 tests here. All right, keep working hard.